Hello and welcome back to another video. Today we're going to finish paper 2 of the AQA Foundation June 2021 paper. Don't forget this is a calculator paper, so make sure you got your calculator ready. Let's get into it. Question 21 says that Lynn works as a bus driver. She is paid £10.80 per hour for the first 38 hours she works each week, and she's paid 25% more per hour for each extra hour that she works. 1 week Lynn is paid £491.40. In total, how many hours did she work that week? The first thing we want to work out is how much Lynn got paid for the first 38 hours, so we're going to do £10.80 times 38, which gives us £410.40. This means we know she had paid £410.40 for the first 38 hours of work that she does. Now let's take that away from her £491.40 we know she got paid, which gives us 81, so we know the extra hours that she works she makes £81. Now since she makes 25% more for extra hours, we know that she makes 125% of her wage. This means that we can do 10.8 times 1.25, which gives us £13.50. This means she gets paid £13.50 for any extra that she works. We can then divide the 81 by the 13.50, which gives us 6, so that means Lynn works 6 extra hours. So she works 38 hours plus the 6 hours, which means she works 44 hours. Question 22 says the square root of x is 4, therefore if we square 4 straight away we get 16, so we know x is 16. The question asks us to find x squared, so 16 squared, if you put it in your calculator, would give you 256. Question 23 says there is a rule for a sequence as after the first 2 terms each term is the sum of the previous 2 terms. First 5 terms of P23 Q57R. Work out the values of P, Q, and R. This one is a little bit tricky to get going, but what we're going to do is we're going to focus on the middle bit here. 23 plus Q equals 57, so we take 23 away from the 57, we get Q equals 34. This also means that Q plus 57 equals R. We know that Q is 34, so 34 plus 57 equals R, therefore R equals 91. The last little bit is P plus 23 equals Q. We know that Q is 34, so P plus 23 equals 34. P therefore equals 11. Question 24, we have been given a triangle. If we look at our triangle, we can see that it is a right angle. And we've got 2 lengths and are trying to find a third. This means we are going to use Pythagoras. Pythagoras is a squared plus b squared equals c squared. C is always opposite the right angle and b can be anywhere. So we have 15 squared plus 7 squared equals c squared. 15 squared is 225 plus 49 equals c squared. 274 equals c squared. Square root 274 equals c, therefore equals 16.6. The next part of the question actually says the length of a b is greater than the answer that we got. What does this mean about angle ACB? If our line is longer, that means it's grown in length, which means our angle must be getting bigger. This means the angle must be more than 90 degrees. Question 25 is asking us to rearrange the equation below to make h the subject. What we're going to do is we're going to do the opposite of everything on the same side of the equal sign as h. This means minus 1 becomes a plus 1, so we get g plus 1 equals 3h. And then we're going to divide by the 3 in front of h, which gives us g plus 1 over 3 equals h. Question 26 is a transformation question. It says describe fully the single transformation that maps triangle ABC onto triangle ADA. Straight away, if we look at this, we can see that our triangle has gotten bigger, so we're going to write the word enlargement for 1 mark. We also need to work out what our scale factor is. If we look here, we can see that we have 1 square in length, but at the bottom we have 4 squares in length. This means our scale factor is 4, as it is 4 times bigger. And lastly, we need to work out a center of enlargement, which in this case would be the very top of our triangle here, which is the coordinate 3, 9. Question 27 is quite a long question. It says a ball contains 500 centimeters cubed of air. More air is pumped into the ball at a rate of 160 centimeters cubed per second. When the ball is full of air, it becomes a sphere with a radius of 15 centimeters. Does it take less than 1 minute to fill the ball? For this question, what we want to do first is work out the volume of the ball with the air in it. We are told the radius is 15 centimeters, so what we can do is use our formula. 4 over 3 times pi times by 15 cubed, which gives you 14,137.17. If we take away what the ball originally contained, we find out how much air we put into the ball, which would be 9,157.17. This means that this is how much air that we added into the ball. If we are adding 160 centimeters cubed per second, we can divide our 9,137.17 by 160. This will tell us how many seconds it took to fill the ball. This means it took us 57.11 seconds to fill up the ball, so yes, it takes less than a minute. Question 28 is a little bit of a weird question. It says p is a positive number and n is a negative number. For each statement, tick the correct box. P plus n is positive. In this case, it is sometimes true if p is 1 and n was minus 1, we would end up with 0, which is neither positive or negative. However, if p was 5 and n was minus 3, we get 2, which is a positive number. P minus n is positive. If n is a negative number, then minus n would become a plus n. This means that we are adding 2 positive numbers, which gives us a positive answer. P squared plus n squared is positive. Any number squared is always positive, so we end up with positive plus a positive again, so this one is always true. For p cubed divided by n cubed is positive, we would end up with a positive divided by negative, which can never be positive, which means it's never true. Question 29 says 250 trains arrived at a station. The number of trains that were late were recorded after every 50 trains. The table shows the information about the results. We've been asked to complete the frequency graph. To do this, we need to work out the relative frequency of the late trains. To work out the relative frequency, we need to take the number of trains that are late and divide by the total number of trains. For the first missing one, we will do 36 divided by 150, which is 0.24. Then 38 divided by 200, which is 0.19. And 55 divided by 250, which is 0.22. Now let's add these onto the diagram and join them with a straight line. Now it says to write down the best estimate for the probability that a train is arriving at the station late. Whenever we want to work out the best probability of an event, we want the highest number of examples. In this case, we want the total number of trains to be the biggest, which is 250, so we're going to take the probability from 250, which is 0.22. Question 30 has given us a diagram of a circle, and it is asking us to say whether AC is the diameter of the circle. In order to do this, we need to prove the 5x plus 40 must equal 180. We need to therefore find out the value of x. To do this, we're going to add everything that we have in the middle and make it equal to 360. First, let's expand this bracket, which would give us 4x plus 40. Let's add them together. 5x plus 40 plus 4x plus 40 plus x equals 360. If we count the excess, we get 10x plus 80 equals 360. Take away the 80 from 360 gives us 10x equals 280. We can divide by the 10, which gives us x equals 28. Substituting this back into 5x plus 40 gives us 5 times 28 plus 40. And if you solve this, you do get 180, so yes, it is the diameter. The last question says a straight line has a gradient of 6 and it passes through the point 3, 19. We want to work out the equation of our line. In this question, m is our gradient, so straight away we can write y equals 6x plus c. Now we can substitute our coordinates into our formula. We replace the x with 3 and the y with 19. This gives us 19 equals 6 times 3 plus c. 6 times 3 is 18. This means that c must be 1. Substitute back in gives you y equals 6x plus 1. That's the end of this paper. Thank you for watching our video. Make sure to subscribe and we'll go through paper 3 in our next one.